welcome to our webinar on this year's second practice problem. My name is Karen Bliss. I am Program Director for MathWorks Math Modeling Challenge, which is a program of Society for Industrial and Applied Mathematics. It's so exciting to see so many people here to learn about this practice problem. Before we get started, I wanted to mention some guidelines. Just so that everyone can hear what's going on, we'll ask all of you to keep yourselves muted unless we specifically ask you to unmute to ask a question. So if you have a question that you want to ask and you'd rather ask it verbally rather than typing it in the chat or something like that, that's fine. If you want to type in the chat that you would like to ask a question, then when we call on you, you could unmute at that time. We are recording this session, so after this is over, we're going to post the recording on our website. If you don't want to be seen or identified, then just leave your camera off and leave yourself on mute, and then you won't show up in the recording. However, we do hope that people ask questions. So you can put questions in the chat. At the bottom of your screen, you should see a place for the chat, and you're welcome to communicate with us there. If you want to type things to everyone, that'll be the best way for us to learn what your questions are. All right. And please feel free to ask questions as we're going along. You don't have to wait until the end, and you can feel free to interrupt us. Okay, so I just wanted to provide a little bit of background before we get started. So I am going to share the screen. I assume you all have found your way to our website before. That's probably where you found some information about us, but this is our website, m3challenge.siam.org. M3 Challenge is a completely free internet-based math modeling competition. So it's a place where we use math and data to solve real-world problems. Teams compete, and the teams consist of 3 to 5 students. And during challenge weekend, which this year is February 28th to March 3rd, that's a Friday through a Monday, you'll choose one day of your choice where you want to log in and download the question, which is kept a secret until then. And once you've downloaded the question, you'll have 14 hours to work on getting a solution, which you'll then upload through that same place where you downloaded the question through the contest platform. And then from there, things move through the judging process. It is completely free to register and participate, and there's over $100,000 in scholarship awards every year. Registration closes February 21st. So if you are not already registered, make sure you get registered before that date, February 21. Okay. I am curious if everybody would be willing to put in the chat, how many of you are competing in the challenge for the first time? Or if you're a repeat, either way, if you would let us know, just out of curiosity. First time, second time. All right, so we've got some people here who's lots of first timers, but we do have some people on board who have done the challenge before. Lots of first timers. Awesome. Well, that's the good news is there are going to be tons of teams that are competing for the first time, so you're not alone. All right. I do want to point out that we have a lot of resources on our website, so I do encourage you to poke around and see all the resources that we have. And if we have time toward the end, maybe I can point some out for you that I think are particularly helpful. But one of the resources that we are going to point out today are the practice problems. So if I'm on the website and I come up here to resources, you'll notice this, this menu item called sample problems. So if I click on sample problems, there are 2 types of sample problems. There's past challenge problems. So these are the actual challenge problems from the past few years. And then there are also these practice problems. And so today, that's what we're talking about. This is the practice problem. This practice problem is called the weakest link. And we are super grateful to be joined today by one of the problem's authors, Neil Nicholson, who is a professor at Notre Dame University. And he's been a longtime judge for M3 Challenge, and he's also a member of the Problem Development Committee. Neil, would you mind sharing a little bit about yourself and maybe why you got involved in M3 Challenge?
Sure. Thanks for having me. Excited to see all these first timers in here. So like Karen said, I'm at the University of Notre Dame in South Bend, Indiana. I've been with the SIAM M3 modeling as a judge for probably close to 10 years now. I've always been interested in writing the problems. And it started a few years after I started judging when I learned that anyone could submit problem ideas. And so I started just doing this for fun. I said, let me take a stab at things. And I would submit them to the problem development committee at the time. And sometimes they wrote back and said, we like this. And then so we developed more. And so I've since moved in to be one of 3 people on the problem development committee. So we meet throughout the year to develop the practice problems, but more importantly, to develop the question that you'll all see here in a couple weeks. And I can tell you this year's is a good one. Can't tell you any more than that, but it's a good one.
I was going to say, I think they're probably going to be typing in the chat and trying to get that information out of you about what this year's question is, but you're not going to tell.
I will give one hint. It involves modeling.
Okay,
So
that's much of a hint, though. All righty, there is going to be a hint that's coming. If you are registered for the challenge, then you're going to get these reminders that come maybe once a week-ish that are called the M3 Minute. And leading up to the challenge, maybe in the week prior, we are going to release a haiku clue. Every year we put together a haiku that gives a hint about what the topic is this year. So that'll be coming out the week before the challenge. If you are registered, you're going to be automatically signed up to get those M3 minutes. If you're not registered, you can click on Get Alerts on the website, and then you can start getting those minutes too. Okay. So in addition to writing this year's challenge question, you were also one of the authors on this practice problem called the weakest link. Can you tell us some of the motivation behind this question?
of course, I think the nice thing about this practice question, if you want to get the motivation behind a lot of our questions, sometimes the motivation isn't in the question itself. But here, when you read the question, we cite some of these big events that have happened recently. There was a shipping container ship that got stuck in the Suez Canal for a while. There was the bridge collapse in the Baltimore area a couple years ago. And we noticed that these singular events had huge ripple effects in multiple areas of society. And we just kind of started to investigate that a bit more. And in our problem, the exposition before you get to the questions in the sample question, we talk a little bit about the Soo Locks. And so if you're not too familiar with geography, you get the St. Lawrence Seaway coming in to the Great Lakes, and where that seaway meets the Great Lakes, there's these locks that boats have to come through. And one of our problem development committee members lives right in Sault Ste. Marie, right by the locks. And we started investigating those locks and realized they're a major hub for world economic things. And we thought, what would happen if they shut down? And that's already been investigated very thoroughly. Some of the links in the problem here, you can see how our government spent lots of time and lots of smart people's brain power investigating what would happen if they shut down. So we wanted to sort of ask about your local communities, you being the teams out there. What's the pinch point in your area? Maybe it's a bus station, maybe it's a bridge, maybe it's a rail line, but try to getting you to think what would happen if that failed, that single point of failure. And so that was the inspiration behind this question. It's a little different from some of our previous questions because we leave it very open-ended. We ask you to identify your local pinch point and your local economic factors that you want to look at, which are great for practice problems because it's something that's meaningful to you rather than one thing that we try to make meaningful for everyone.
Maybe I my memory is that you all were working on this question. Maybe you can correct me if I'm wrong, Neil, but you all were working on this question even before this bridge collapse happened, didn't it? This key bridge collapse in Baltimore. I feel like you already sort of had this question in the works, and then when it happened, I was like, here's a prime example. So this is pretty recent in my mind that there was this container ship that ran into this bridge, and suddenly this major thoroughfare was just gone, right? Immediately. When I pulled up the Wikipedia page for this, I immediately was drawn to this number, right? So I'm just reading through the Wikipedia page, and it says the economic impact of the closure of the waterway has been estimated at $15 million per day. And one of the things that was striking to me about this Wikipedia page was you can see they have citations for all sorts of things, but there's no citation on that number of $15 million a day. So I immediately thought to myself, I guess because I've been working on the challenge for so long, it's like, where did that number come from? And that is actually really related to this first question in the challenge. So I'm going to try and bring that web page back up. And so if you haven't had a chance to read through all of this, I do encourage you to read through the intro, but I'm going to go ahead and move on to the first question. The first question is, if your chosen vulnerability, so you'll remember that Neil said, basically, you're looking at a vulnerability in your own community. And if you can't think of one, you're free to use someone that's not, you're free to use one that's not in your own community, but it's sort of nice to think about like something very local, actually. If your chosen vulnerability fails, quantify the economic impact of that failure for periods of 1 week, 1 month, and 6 months, assuming, so for this question, we're going to assume there's no alternative plan for replacing or avoiding the infrastructure that exists. Economic impact can include impact on jobs, trade, gross domestic product, tourism dollars, tax revenue, and more. Feel free to focus on just one or a few of these factors and use data to support your modeling when possible. Okay, so now that I've read all that, I'm curious to know, when teams start working on a question like this, how do you think they might even get started? What would you suggest, Neil?
I think starting with just a conversation amongst your team. How do you interpret the question? Interpretation is a big part of this competition because sometimes the questions are a little more open-ended. This one in particular is quite open-ended because feel free to focus on one of these things. Feel free to focus on a few of these factors. Which vulnerability do you want to focus on, and which economic impact do you want to focus on? If I were a first-time team and I was going to say, let's take a couple hours this afternoon, let's have a modeling practice, I would just say, let's do one thing, one small little modeling thing. Maybe let's just look at a very tangible one. Transportation in I'm thinking of my hometown where I grew up. There was one bridge over the river. And if that bridge failed, you'd have to go like 30 miles the other direction to get to the main town. And maybe my team might let's look at the people who are going to have to miss work because of this bridge. So having a discussion on how we want to define the question. If you look
That's a
at
big
past,
deal.
oh, go ahead, Karen.
Yeah, the other thing I was going to say is that I feel like I know I looked at this question and I thought to myself, um, I don't uh, I don't feel like I'm qualified. I don't feel like I'm qualified to answer this question. I don't know so much about gross domestic product or tourism dollars or, like I don't know so much about those. Do you ever feel that way? And what do you do in the face of like, I don't know if I even know how to answer. I don't even know how to get started or think about this.
I 100% agree. I don't know how tourism dollars are calculated at all. I don't know, like you said, gross domestic product. I think the things that maybe a novice modeler that are important is figuring out how to define this question so you do feel a little bit of confidence in it. Here, when we talk about an economic impact and jobs, let's look at that very first one. That's a huge word. How do you quantify jobs? And so you kind of go from the broad to the, maybe we're going to quantify it as new jobs added. Okay, so now we're getting a little more specific there. We're getting something that we can work with, or jobs lost, jobs that go on a 2-week hiatus while this bridge is broken, while the bridge isn't operational. Okay, I'm getting somewhere with it. Modeling oftentimes is going from a very vague, kind of cloudy interpretation to something very specific. When you write your solution papers, one of the tips I can give is make sure you're very clear in what you're defining this thing to be, so that someone who's not invested hours and hours in the project will know exactly what you're doing. We're going to investigate jobs. I won't know what you mean, but if we're going to investigate number of jobs lost during the vulnerability fail, okay, that means something to me. So going from the general down to a meaningful specific is probably a good place to get started if you're
Yeah.
nervous or unsure. But it's okay to be nervous. I'll say that probably 10 times today, or to feel a little lost. I feel a little lost anytime I read one of these. Don't know where to start, but let's figure it out. Let's have fun.
If you were in the middle of the challenge, I could see maybe a good plan for this would be like to say, I don't know. First of all, we all can think about which ones we think are the most important, right? And then you've got a team. So maybe you say, hey, you go just do some surface level, how do we figure out tourism dollars, or how does one compute? I don't know. You might split up the work and say, I'm going to focus on this factor. I'm going to read about it for 15 minutes and orient myself and think about what is involved in that, and then come back together as a team and say, all right, that seems, I don't know, that one seems reasonable. I think we can start to quantify something there. Or maybe you say, we're not touching that one. It sounds like it's too much. And I think that's a really good way to go. I would say, and you've been a judge for years too, that that judges are probably going to be more open to which factors you included than thinking really hard about which factors you didn't include, if that makes sense, right? So they're going to be like, oh, that's clever. You guys thought to think about X, Y, and Z. I didn't even, yeah, that's great. I'm glad they thought of those. Would you say that's probably true?
Spot on. I think as judges, we very much value quality over quantity. If you're using 3 factors and you've really dived deep into them and thoroughly explained them, supported them, justified them, that's fantastic. Versus we looked at 18 things, but we only went, an inch deep on each one, and half those things we really didn't show that we understood what was going on. That makes for sort of a weak solution. I really liked your point about using your team. You know your teams well. Different personalities have different strengths. Dividing and conquering is a great way to sort of start the process. I don't mean that as in you attack question 1, you attack question 2, I'll attack question 3. But in the initial brainstorming process, I think dividing and conquering, you go look at this data. Is there anything there that seems meaningful to you? I'll look at what we know about this factor, and I'll see if it's meaningful. And then we'll reconvene in half an hour, see what we came up with. That's a great use of your resources and your time.
And how do you think, like at the end of the day, we're looking for something. I mean, I see mathematical modeling in the title. How do we get to something mathematical when it's all said and done?
The data, and in particular, what the question is asking a lot of times will lead you into certain mathematical tools. There's not a right solution here. Some teams who maybe are a little more advanced mathematically, right? We have some 2-time teams in here. Maybe some people have been doing modeling for 3 or 4 years, and they've taken a little more advanced math than that younger team, and that's just fine. If you look at the data, and maybe it's a time series thing, we're trying to predict something 5 years from now, and the data is lending itself to some sort of regression or something like that, versus if it's change and if the team knows maybe a little bit more about differential equations. Those are both great solutions, and we don't necessarily as judges weigh the higher level math against the lower level math. We weigh the quality versus the quality. So are you using your tools that you're developing appropriately, and are you explaining it well? That's so much better than maybe using a math thing that's beyond you and not using it the right way.
Yeah.
But I think the data there, maybe that's a short answer to your question. The data can sometimes help you figure out what math to go with.
Yep, that makes sense. So at the end of the day, though, I do want to mention there should be some math on your page. We are not prescriptive in what the math is. It doesn't have to be calculus. It doesn't have to be algebra. It doesn't have to be statistics. It doesn't have to be any particular kind of math. As long as there's some math eventually, right? So at the end of the day, we're hoping that you quantify something, and it's often about making a prediction about something. I guess I couldn't say it's always about that, but it often is. And I was thinking about this particular question, so still thinking about question one for just a minute. When I saw that it said, what's the economic impact for 1 week versus 1 month versus 6 months, is in your mind, is that just a matter of multiplication? So for instance, if I could come up with an answer for 1 week, do I just sort of multiply by 4 to figure out the answer for a month? Does that seem appropriate?
Again, I think the scenario is gonna dictate that. If I'm, for example, let's think about I'm trying to think of some specific things. People missing work because of the bridge that's down. If you're on one side of the bridge and for the first week you have to operate remotely, and the second week you're still going to have to operate remotely, the number of people isn't going to change. But if you're quantifying the number of hours of work that becomes remote work, well, then you're going to multiply that by 4. If it's something maybe where there's an initial spike in some sort of loss. I can't think of something off the top of my head, but immediately a lot of stuff stops. But then once it's maybe if it's a one-time loss, then you wouldn't multiply those things by 4. If it's things along those lines.
So you could imagine some factors being things that the initial loss is huge, but and maybe it's not related to this question because we said, to assume that there's no alternative plan. But I could imagine in general that there's some initial cost, and then it sort of subsides and it's not as big of a deal after time. But I could imagine some factors being the opposite, right? Where it's like, okay, I'm okay for a little while without having access to this thing, but eventually it starts to really become a painful thing. So I could almost imagine both. And then I could think of things for which you're saying it would stay constant and I would just be multiplying. So there's no one particular answer here. Yeah.
Exactly. And when you were mentioning this, I think of, for example, let's suppose you've got a supplier of food on the side of the bridge and they can't get food to the other side of the bridge. For that first week, grocery stores have enough food to provide the town with food, but maybe after the second week, the food starts to dwindle, and all of a sudden, so you can see sort of it's a small impact for the 1 week, but after a month or 6 months with no alternative plan, this becomes a major issue, versus the opposite, where you've got something that's an initial shock to the system that tapers off. Even if you just think about just math, graphs of certain functions, you've got those functions that are really steep at the beginning, but then level off, or you've got like a quadratic function that's slow, but then it takes off real fast at the end. The scenario might dictate what type of math you're looking at.
Okay. So we've been talking a little bit about data, and I noticed that there isn't any data provided for this question. And that is in part the nature of this question, which says you should choose something that's near you. For actual challenge problems, we do usually provide some data. And I think it's not a secret that there will be some data provided with this year's question. Maybe I did let some, yeah, there will be some data. Now you have a leg up, everybody. There's going to be some data this year. What can you share about the data that is typically provided for the challenge? Should teams be just focusing on this data? Should they look for more data?
If you go back, Karen, you've got a longer history with the problem writing than I, but maybe about 5 years ago, 6 years ago, we decided to start providing data to teams. I believe maybe my clock is off and maybe it was 10 years ago.
It
Because
maybe we started before then, but we've pretty consistently since 2018 for sure.
okay.
And it could be that we provided some even earlier than that. Yeah.
So I think what we realized maybe in the early teens was certain teams were having really good solutions because they found really good data. And other teams were struggling because maybe they spent a lot of time looking for data and then didn't have as much time to solve the problem. So the providing of data is, it's not necessarily to level the playing field in terms of the math that you can build or how you can think about the problem, but I think it's leveling the playing field in that if you don't want to use your 14 hours to go find data, you don't have to. So we're going to hand you some data in the problem here in a couple weeks. You can choose to use that data, or if you build a model and you want some other data that's appropriate for your model that we don't give you, we're just fine if you pull in other data and you don't even touch our data, so long as you're citing it, that here's this data, here's where we found it, here's why it's valid data, right? It's from a decent source. So the data we hand you, you shouldn't think we have to use everything that we give you. I think a great way to, if you're confused about what we're saying, Karen, if you look at one of the past questions, like if some folks go on and look at last year's question about housing and unhoused persons, do they have access to the data sheet on your website as well?
Sure do. Yep.
So you can look at some of the winning teams' solution papers, and you don't have to read them line by line, but you can see they don't use all the data. Some of the teams use a lot of it. Some of the teams use very little of it, and that's okay.
Absolutely. Yeah. I think it's worth saying that we have tried to provide the data that we think is the most valid, right? Like we tried to find the data that we think is most useful in answering the question, but part of that's a little bit of a game because we're guessing about how you might solve the question. And I don't know how you're going to solve the question because it kind of depends what you thought was the most important. And everybody's answer looks different, right? That's the sort of awesome thing about math modeling is that it's always everybody's solution is different, but we do our best to guess what might be useful. And it's so in some sense we've tried to provide what we think is the most useful because we don't want teams to just spend hours and hours looking for data. But maybe we missed the mark. So you could spend some more time looking for data, and maybe the data that you need to answer your particular version of the question, how you've defined it, we just didn't provide that data. Or it could be that we tried to find that data. We also thought it would be useful and we couldn't find it. And so, yeah, so I would say there's some sort of balance there, which is if you go looking for data, don't let yourself down some rabbit hole of where you just keep looking for the data and hoping that next click is going to give me the data that I need. Because it's super easy to end up in that place where you just keep looking for data and you don't make any forward progress. So at some point, it's okay to step back and just say, you know what? I don't have the right data. I'm going to make an assumption. I'm going to assume this and I can move on. And that's a perfectly valid thing. And then at some point you can write in your solution when you write about this, hey, I didn't have time to find the data, or I didn't find the data that I wanted. And so if I had some more time, I might try and get my hands on this data. Or if I had some more time, I might at least try and come up with a better approximation for this factor. But this is what I did in the time constraint that I had. And That's a place where this, where there could be improvement if I had a bunch of time. Yeah. Okay. I think we should move on to the second question now. So I am going to do the thing that I do encourage all of you to do when you're reading over the challenge question, is that I actually encourage you to read it out loud. I think that's actually a really nice thing to do. It makes sure everybody understands what all the different questions are that you're going to answer. And reading it out loud helps you to slow down and let it sink in. So I'm going to read it ahead. I'm going to read it aloud. Determine one alternative route or plan that does not include your chosen vulnerability. Use mathematical modeling to determine the extent to which an alternative can mitigate the economic impact of your vulnerability failing for the same periods of time as in question one. Okay. Maybe before we even start thinking about this, or maybe before I ask Neil to weigh in on this, maybe we could ask everybody if they would in the chat think about, you don't have to think about what your mathematical model is going to be, but what sorts of things would belong in this mathematical model? Does that make sense? What sort of factors would you want to include? What would be important to include? And anything works, like throw anything out in the chat. What would you want to include? So we're going to try and come up with a plan and model the extent to which that can mitigate the economic impact. What sorts of things would you want in a model that would talk about how to mitigate the economic impact if you had an alternative plan? So that bridge went down. Okay, travel time. Yeah, that's a good idea. The bridge went down. We're talking about a different path, and we're going to think about how does that alternative path help solve the problem? What sorts of things belong? Distance, accessibility to the detour. These are great answers. Average speed of different modes of transportation, right? So if I can't get across that bridge and I have to take a train or I have to whatever, yeah. Width of the road, yes. Going to let people provide some more options. And if you've provided one, you're welcome to provide others. Perishability of goods, good one. Cost. Yes, cost matters so much, right? Yeah. Where people working in high output areas of Baltimore live, right? Absolutely. Okay. Neil, do you have anything to add to all these factors that everybody's thrown out here?
No, I think they're all great. And I think all of that, any one of them could be like the most important thing relative to what you've defined as your economic impact and your vulnerability is in this problem. If I'm dealing with the grocery issue, perishability is going to be a really important thing. If I'm dealing with something that does, jobs lost, perishability maybe isn't, but some of the, time to travel the 30 miles in the other direction. Is it a 1-lane swervy curvy road, or is it a 3-lane interstate where people go 80 miles an hour? Right. So all of your answers here are great.
Yeah, I think remote work has really changed this game too, right? Because I think in the past it was like, well, if all these people can't get to work, what are we going to do? There's a viable alternative in remote work for a lot of jobs. Not all of them, but for a lot of jobs, there is a viable alternative. But there's consequences to that, right? So quantifying those and thinking about what sorts of things might be impacted in that respect is important. So as I'm looking through these, and we've already established that there's no single one correct answer to these questions, which probably feels weird if you haven't done this stuff before, right? Because you're used to math being the thing that has the, like I get to put a box around my correct answer. So this feels different. But even if we know there's not one single correct answer, what would you say what are judges looking for? Is there any one of these that like teams should steer themselves to because judges really like that one?
I would say don't try to predict what the judges want, because we as judges don't know the answer either. We're looking for you all to give us some answers. The majority of the judges, and by majority, I think I probably mean about 98% of the judges, who don't know what the question is either. They won't know it until they get their judging materials after the competition's over. So there's only a few people who know what this is. So they're new to it as well. So they won't have a chance to think about it. So I think knowing that, it's really important for you as a team to support your solution. Tell us why you think your solution is what it is. Why is it so good? At the same time, what you put into it, you're going to support. Like, here's why we're including the factors that we're including. There's a maturity in the modeling process when you realize it's also important to recognize what you didn't do, or the flaws in your model. We didn't include this factor because of blank, and that's a weakness of our model. That's okay, and it shows really sound modeling to say this modeling could be better if we'd have included this factor, but we just didn't. It's okay to say those things, and I'll encourage you to do that sort of step back and assess yourselves kind of
Yeah,
approach.
that's another place where I feel like the challenge is different than a lot of other things, pieces of writing in this case that students might have done before, in that you're supposed to come up with an idea and defend it and explain why yours is the right answer. And I want you to do all that. I want you to explain your solution, and I want you to, you know, be proud of the work that you did. And then also, it's okay to say, but I didn't include every single thing. And maybe it's a strength that you didn't include everything, because if you included every single thing, nobody could understand your model, right? And it would be very hard to use, and it, you know, it wouldn't be great. But you could say, you know, hey, I would have liked to have explored this or that, and that judges actually think it's a really good thing for you to say what you didn't get a chance to include, and what you might have included, and how you might have included it. Those all make you look better if you can include that. Yeah, that's a really great point. Okay, I'm going to move on to question 3. And so for question 3, I'm going to read it. For your chosen vulnerability, consider a preventative measure that could be taken now, which would reduce the chance of a failure or mitigate the impact of a failure. Create a mathematical model to determine if it is worth investing in this preventative measure. Okay, so what do you think? Again, I want everybody to weigh in. If you want to add something in the chat, what would be important to think about as you develop a mathematical model here about a preventative measure? If it helps you to think about that key bridge that went out, you can, but you don't have to be thinking about that one. You can think about something closer to you. But in terms of like, at the end of the day, we're hoping to come up with some way of deciding, should we or shouldn't we put a preventative measure in place? So yeah, so what are the things that we should consider? Chance of failure, so important, right? The cost. Yep. I'm reading all the amazing answers coming up here in the chat. Cost and time to set it up. Yes, time. Cost. I'm going to wait for a few more answers, give everybody a chance to think about this, what sorts of factors they think we would want to include if we were trying to decide whether to put a preventative measure in place. Public support. Yeah. How much would we save? Effectiveness of the preventative measure. Reliability of the fixed solution. Okay, what do you think, Neil?
Great answers. The one thing you'll see when you look at a lot of these third questions that we come up with, if you look at the past actual questions, is they're typically pretty open-ended, and so there's always some interpretation that goes in there. A lot of times these require a little more reflection on your part. So if you're dealing with costs here, recognizing that some of those costs are actual costs, some of those costs are opportunity costs, or preventative, you know, you're saving money down the road. If you're going to work in chance or probability, are you working that in the right way? Expected costs, all kinds of great things that you can do there.
Opportunity cost is one that I personally have. I always have to stop and pause on that one, and I think it's a really good one that can apply to a lot of different questions, and in particular, anything where we're talking about what should the policy be? How, how should we spend money to fix this problem? Because if I'm talking about spending money to put a preventative measure in place, so in the case of the bridge, putting in some sort of alternative bridge or whatever, some sort of path that could to get me around, right? If I'm thinking about putting that in place, then I'm spending that money, and that means I am giving up the ability to spend that money elsewhere. And that elsewhere doesn't have to be around, in my case, transportation. It could be anywhere elsewhere in the economy, right? That some sort of public entity could be spending that money. And those things I think matter, and it would be interesting to see how to incorporate them. But yeah, like thinking about that, I think has mattered a lot of times in past challenge questions in ways that it's super interesting when people consider that.
Very much.
Um, Yeah, yeah. I was also looking at like one of the things that I thought was interesting was public support. Um, and that one is super interesting to me because I think that one matters a lot. And it almost is sort of tied into that opportunity cost, right? Like if I'm going to build this whole other route to get around this bridge, and that would potentially spend a lot of money, right? That's that opportunity cost. Even if we think there's a really good chance that there's going to be a failure at some point, and we would want to avoid that catastrophic thing, having public support would matter a lot. So it would be super interesting to think about how I might model that, right? And how, and in some sense, if you think that this is the right thing to do, is it worth spending money to get public support, if that makes sense? Would it be worth, and so like I could imagine a really interesting, really cool model built around that, right? How much money would I have to spend so that I could get the public support because I think this is an important thing to do? That would be super cool. Okay, so what do you and any insight you might have on like what a mathematical model might look like for this question, Neil?
That's a hard question. I think one thing that I'd probably want to say here, and I think I'll piggyback off your last comment about the public support. I never thought about the public support as being a solution to this question. And it seemed like it'd be a really interesting model. How you would like what math would you get involved in it? You're gonna definitely have to bring in things like maybe some social statistics sorts of things, right? Dollars spent in, I don't know what much about advertising, but political messaging. One thing that I think relative to whatever math you use in one of these large questions, like this is a great example of a question that can get really big really fast. Don't try to bring in every factor. So this one, if you think, well, we got to bring in tax revenue. I don't know a lot about taxes, but I know it's a huge thing. Property taxes, income taxes, social tax things, different areas pay different things, tax brackets, but then you bring in, okay, now we're going to bring in advertising firms, and they're going to do some sort of, they're going to spend money to survey people, but they're going to spend money to influence. All of a sudden, you've got a million things to build this model. Be careful not to try to do everything. We recognize you are high school students trying to answer questions that people with PhDs struggle to answer. We don't expect you to come up with the world's greatest solution in 14 hours. So pulling back and trying to focus on what you can control, one or two things, and doing those really well. And if you have to make some assumptions in there, that's great. Assumptions are wonderful. Just justify them. Tell us why you're making that assumption as well. So that really doesn't answer your question, what math you're going to use. I would just say make sure you temper it a little bit. Don't try to, particularly with question 3, don't try to do way too much.
So there is a question in the chat, and somebody said, is it normally A-level math and FM level? And I am not even sure what that means, but
Is that,
um,
I'm going to guess there we go. They stole my
yeah.
answer. Was that UK stuff?
Yeah, I thought so. Yeah. So, but in answer to, so I'm not exactly sure what A-level math means, but I can say this. There's no particular math that's required. There's no, like prerequisite that you have any particular math that's involved. We've seen some amazing solutions that involve addition and subtraction and multiplication in various ways. And we've also seen plenty of times if you're taking calculus where someone has decided to use an integral where it was really unnecessary, right? Like they're like, I'm in calculus and I feel like everything has to do with integration, so I'm gonna use integration. There's times when that was appropriate, and then there's times when that wasn't appropriate, and really like addition and multiplication were sort of more appropriate. So in answer to your question, anything is okay, right? So it just is helpful for you to use the tools that you already know, and as long as you justify those tools really well, you'll do great. Yeah, that's my best answer to that. I want to point out one more thing about this practice question, and then I think I want to point out a few other resources. But I'll remind everybody, if you have questions, it doesn't have to be about this practice problem. It could be about anything related to the challenge. Please go ahead and put them in the chat, and we'll work on answering those. But in the meantime, I wanted to point out that this practice problem does have 3 different questions associated with it, right? So you can kind of see the 3 different questions that we went through. Do you have any, and that's true of the challenge, the actual challenge questions, right? Is that they usually have 3 parts. Neil, do you have any suggestions for teams about how much time they should be spending on each of these parts of the?
Not so much spend 6 hours here and 4 hours here. I don't think your team should go into it thinking we need to spend an hour in preliminary prep, or let's say 2 hours to make the division easy. So we've got 12 hours left. So we're going to go 4, 4, 4. I wouldn't come at it from that point of view. I would look at it as let's attack question 1. Let's understand what's going on in question 1, because in building your solution to question 1, you're not going to be writing 3 different solution papers. You're going to write 1 solution paper. And a lot of that preliminary stuff that goes into question 1 is going to carry over into question 2, going to carry over into question 3. Write a really good, sound question 1. If you're a first-time team, Karen may touch on this, but there's an additional award for a really good question 1 solution only this year. So if you're a first-time team and maybe you say, you know what, we know we're not going to be the #1 team in the country. There's nothing wrong with that, right? Everybody except one is not going to be the #1 team in the country, in the world, right? With UK participating. But you can really get some stuff out, really good personal gains from diving into question 1 and then starting to get into question 2 and see where we get. And play it by ear. You may find yourself on a roll and you're doing great, and then all of a sudden you've got an hour or 2 left and you say, let's take a stab at question 3. But I would not go into it and then say, okay, our time is up. Let's stop what we're doing on question 1 so we can start question 2. As a judge, not as a problem writer, but as a judge, I would much rather see a complete question 1 solution and then attacking some of question 2 rather than question 1 was 60% done, question 2 was 40% done, question 3 was 15% done. That's my suggestion.
Yeah, and I've seen successful teams too that tell me that they actually have already set aside, like dictated in advance how much time they were going to spend on each question. And invariably you get off of that, pretty quickly. But thinking about, some sort of level of divide and conquer, whether that's time or, the people on your team and using their strengths appropriately, like thinking about how they're going to do it. There's always going to be, you're going to be surprised by the question, and then when you see it, you're going to think, oh, how to get this going. It is also true that pretty frequently in questions, sort of, and maybe it's a little bit true in this problem that we've just looked at. But sometimes it is the case that you need to use your solution from problem one to answer question one to answer question two. Sometimes not. And it's often the case that question three builds somehow on the first two. So having good solutions for those first two is almost like necessary before you start tackling question three. So there's that to think about too. But when it's all said and done, I feel like there's, the opportunity to just have loads of fun in this whole thing. Like, I think you can worry about, like, did I have exactly the right thing? Did I do that? And I hope everybody thinks that this is an opportunity to get together with a team of people and like really get a chance to dig into questions in ways that you don't often get a chance to. And that's really super cool. I have had the opportunity, I don't know if everybody knows this, but this is actually the 20th anniversary of M3 Challenge, which I have to take a deep breath and think to myself, the people who are competing in M3 Challenge this year were not even born when M3 Challenge started, and that's crazy to me. But yeah, so we're entering our 20th anniversary, and in part of our celebration of the 20th anniversary, we've been reaching back out to past winners of the challenge, and we've been talking to them, and I am fascinated by the number of past winners who said, this made a really big impact in my life. I didn't know that I could use math this way, or I didn't know that, that the impact that, being able to use math and data to solve real world problems, I didn't think I could do that as a high school student. And I felt powerful by doing it. And it really impacted me and made me, think about, things that I could do with my career and with my life that I hadn't thought about before. So, I know we've been spending a bunch of time talking about, what's the best way to answer the challenge. But I also think you should have fun and just like get ready to dig in and be like, you get to define this problem in a lot of ways. It's different for every single team, what they're going to focus on. So that's really cool and really powerful. And I hope that you all get that from it. Okay. Let's see. I'm seeing a question right now that says, do you have any tips for the division of work among the team? So if you're a team that's working for the first time, anything that you have about, any advice you might have about navigating the problem as a group and doing that brainstorming? Neil, do you have anything that you would want to weigh in here?
I would have a discussion with your team before competition weekend to get to know each other's strengths. That if you have a really good, let's say someone who's really good with programming or using Excel, you want that person working with the data. You want that person as your data person. You don't want all five of you doing the same thing at the same time, but at the same time, you don't want five totally disjoint people. You each write 3 pages and then we're just going to slap them together at the end. If you've got someone in your group who's really good at writing, you're going to want that person really working on your solution guide. Maybe you've got people who work good together. The brainstorming process at the beginning, I think having multiple people involved with that doesn't have to be everybody, but there's a reason brainstorming usually takes place in groups because you grow off of each other. That would be my advice: is know each other's strengths and divide appropriately.
I'm going to point out on a few places on the website. So if you'll see, I've navigated at the top to resources. I'm just going to go ahead and click right there on resources and show you what's on our resources page. So, and maybe I'm going to stop this from moving. I think Melissa dropped in the chat earlier links to these math modeling handbooks. These were specifically written for the challenge. So they're really friendly. They're, I think, pretty easy to understand and some interesting questions. So if you have some time to look through those, That should give you a sense of going all the way from the brainstorming process to like actually coming up with a solution and some results and how to write about them. We have the tips and guidance page, which I'll point to in just a minute. There's a challenge checklist. So if you've never done this before, that can be a good way to keep you, sort of on track. What are the things I'm supposed to be doing? We have the sample problems. Today we went through one of the practice problems, but there's all the old challenge questions. If you are going to look at an old challenge question, on each one of those, we do have the winning solutions from that year. So we have the top 6 solutions, and then we have the technical computing solutions as well. I would point out that there are also these, there are 3 sort of sample papers that are associated too. I feel like people can get intimidated if they're looking at those very top best papers. Those are the top less than 0.5% of solution papers, right? Like that's what those top papers are. I would encourage you to look at those other papers that are on that page. We have like sort of an average solution and one that's above average. And so those can be papers where you can get a sense of like, oh, okay, this is maybe sort of what a solution might look like. There's information here about learning technical computing. The scoring guide can be super helpful, right? You may want to look at that generic scoring guide and say, like, what is it that the judges are going to be looking for in a solution paper? I do encourage you to look this over in advance because one of the things that teams that are first timers often overlook is this executive summary. So typically you're going to write your whole paper or most of your paper, and afterwards there's a summary, and it's just the front of one sheet of paper. I guess you're typing, so there's no actual paper involved, but it's one page and you summarize the questions and your results. And basically it's supposed to make it so like, oh, I'm going to want to figure out what math they did. I want to figure out what they did to come up with these results. So it's sort of getting the judges excited about reading your paper. That executive summary counts a lot. So look through the scoring guide, I think, and make sure you understand what belongs in that executive summary. If you forget that executive summary, it can be a big deal that it's not there. So I don't want anybody to forget that. And along those same lines, we have a set of solution templates, as if Sarvesh is asking, and I have just found it on the page just as you're asking. We have 3 solution templates available. So if I come over to the solution templates, there's a MATLAB solution template. You are not required to use MATLAB. If you're competing in the challenge. If you do use MATLAB or any technical computing software, you're welcome to, you are then able to be eligible for those technical computing awards, but it's not a requirement in any way. Okay, so there are 37 awards. I think only 3 of them are technical computing awards. So if you want to use MATLAB, you're welcome to, and there's a template for that. There's a Word document. This one's probably the easiest one to use, so it's the one I would probably most recommend is using that Word document. And it also has really nice tips built in about what should belong in each section. And then we have noticed teams using LaTeX. If you know what LaTeX is, and you've had some training in LaTeX, there's a template for you. If you've never used LaTeX, I do not recommend picking it up in the middle of the challenge and trying to use it for the first time. And that's all I'm going to say about it. As a practicing mathematician, when I was doing research, this was the software of my choice, was LaTeX for typesetting. It produces beautiful mathematical equations, but there's a pretty steep learning curve. So I wouldn't recommend using that one if you've never used it before. I would go with the Word template. Okay. So Arnav is asking, I didn't hear the last few seconds. Do we need to use MATLAB for technical computing awards? You can use whatever technical computing software you'd like. So Python is absolutely good. Any technical computing software you like. The only thing that doesn't count for technical computing awards is spreadsheets. And as a reminder, right, technical computing in general is not required. So if you feel more comfortable with a calculator, if you feel more comfortable with a spreadsheet, absolutely use them. So those are perfectly good tools to compete in the challenge. And using technical computing doesn't elevate you in terms of most of the prizes. Just those 3 technical computing awards are hinge on you using some kind of software. Okay, I'm noticing that we've run out of time. If you have more questions, feel free to reach out to us at M3Challenge at SciAm.org. And I want to say thank you to Dr. Nicholson, and thank you to Melissa, who's been popping all this stuff in the chat for us. And thank you to you all for coming. I'm so excited to reveal this year's question in a few weeks. And we do have 2 more webinars in the coming weeks, so we hope you'll join us for those too. Yeah, thank you so much, Neil.
Thank you all. Great to see you.
Thanks. Bye.